Bismillahirrahmanirrahim. So now moving on to the last topics of biostatistics, which is the chi-square test of independence. Before we start this, let's recall that we had basically three topics of biostatistics this year. The first one being sample size calculation, the second one being the t-test, and the third one being the chi-square test. Now that we are done with both of them, alhamdulillah, now we'll be moving towards the chi-square test. So the full name for chi-square test is the chi-square test of independence. So let's see what the chi-square test is. So before that, we have already covered the t-test, and last year we covered the z-test. So this one is the last of the tests that we have to cover. So the chi-square test. So what's the basic idea of a chi-square test? At times we are required to classify individuals according to different qualitative variables. So basically we have two kinds of variables, qualitative and quantitative. We studied about them last year, so if you really want to go into much more detail, you can go to CHSME part 1 and see what we discussed over there. But for now, just remember that we have two kinds of variables, qualitative and quantitative. Last year we had nominal, ordinal, interval ratios. So you can go into that detail, but for now just remember that we have qualitative and quantitative variables, and for chi-square we are actually concerned about qualitative variables. So for example, in a study, pregnant women were classified according to two qualitative variables, smoking and drinking. The question of interest was whether the smoking habit of pregnant women have any effect on their drinking habit. So basically we are actually comparing between two qualitative variables. So let's see, what is the purpose of chi-square study? So unfortunately there was a typo over here and we missed out in the notes what was the purpose of the chi-square study, but here we can actually see what was the purpose of chi-square study. So the purpose of the chi-square study, at times we are required to classify individuals according to two different qualitative variables. So as in the example we discussed above, we had pregnant women who were smoking and the same pregnant women who were drinking. So these are two qualitative variables. So according to two different qualitative variables, smoking, drinking. For example, in a study, pregnant women were classified according to two qualitative variables, smoking and drinking. The question of interest was whether the smoking habit of the pregnant women have any effect on their drinking habit. So basically, we find out the relationship between those two qualitative variables. So whether those variables are dependent upon each other or whether they are independent. So let's see. Okay, so next question. What kind of data do we have in a chi-square test? We have more than one row, two or more than two of data in chi-square test. So basically we have to compare. So comparison isn't possible with a single set of data. So basically we have two or more than two sets of data in a chi-square test. So what is the unique feature of data in a chi-square test? So basically all the data in chi-square test is qualitative. So basically a person can be a smoker or cannot be a smoker, or can be a very heavy smoker, but this all is qualitative. So if you recall, we have two kinds of qualitative data, nominal and ordinal. So in nominal, either a person is a smoker or isn't a smoker, but in ordinal we have a complete spectrum of things. Like for alcohol consumption, if we have to classify it according to nominal data, we'll say that a person is a drinker or a non-drinker. But if we classify it as an ordinal qualitative variable, we'll say none, low, medium, high. So basically we'll have a complete spectrum of things, but both of these data come under the heading of qualitative variables. So the thing about chi-square test is that all the variables used are qualitative, or they are also called categorical variables. So both of them, they are the same thing. The bottom line being that qualitative data is the hallmark of chi-square test. Then the chi-square distribution is positively skewed. So if you recall from last year, we had three kinds of graphs. One was positively skewed, another was negatively skewed, the third one was normal. So how does a positively skewed graph looks like, which is for chi-square? So basically this graph, which have the peak skewed towards the y-axis of the graph. This is called the positively skewed data. So this is the positively skewed data. This is the positively skewed data. So this is typical for chi-square test. Okay, so moving back. Okay, then there is something called the contingency table. So what's a contingency table? So if you recall, we typically use a 2x2 table to summarize the results of various tests. So the 2x2 table, which summarizes the result of a chi-square test, has been given the special name of contingency table, nothing complex. So sometimes the contingency table may have more than 2 rows or columns. So 2x2 table is for other tests, but a contingency table may have more than 2 rows or 2 columns, but the idea is the same as a 2x2 table. So basically it is used to summarize the results. So basically now we'll see what formula we use to calculate chi-square. So chi-square is represented by this x-like symbol. So this is called the chi-square. So chi-square, x square, this is the chi-square. Then this symbol is for the summation, or it is used to denote that we are actually going to sum up this thing. So basically we'll calculate this thing for various set of data, and then we'll add them together following the command of this symbol. So this is sigma, which means sum of. So then O, which is the observed frequency, and E, which is the expected frequency. Then we take a whole square and then we divide it by E. So this is the formula for chi-square test. So what are the steps in a typical chi-square test? Let's see. So we'll use this example to demonstrate various steps in a typical chi-square test. So we have these two researchers who published a study of the effects that maternal use of alcohol during pregnancy have on the newborn. Some of their data regarding smoking and drinking by pregnant women are shown in table 1. Okay, so over here we have, so this is the set of population that we are having. So we have these smokers and these non-smokers, then we have the people who are consuming alcohol. So this column represents people who did not ever consume alcohol. These people consume alcohol in low amounts. These people consume alcohol in medium amounts, and they consume alcohol in high amounts. Whereas over here we have smokers. So this row represents all the smokers, and this row represents non-smokers. So here we see that 30.5% of the non-drinking women, so, and 67.3% of the heaviest drinkers smoke during their pregnancy. So 30.5% of non-drinking women and 67.3% of the heaviest drinkers smoke during pregnancy. We might wonder whether drinking and smoking are dependent variables or the relationship is explainable by chance. So basically what we have to see is there a relationship between these two variables, smoking and alcohol? So is there a direct relationship, or is there any indirect relationship, or this is simply by chance, there isn't any relationship? So to establish this thing, we have to conduct a chi-square test. So chi-square test basically will tell us that whether there is a relationship between alcohol consumption and smoking status, because over here if we just crudely see these two things, we'll definitely end up guessing that yes, there is a relationship between alcohol consumption and smoking, because those who consume zero alcohol, they end up being smokers in just 30.5% of the cases, but those who consume high amounts of alcohol, they are 67.3%, almost double percentage. So basically, crudely speaking, yes, there is a relationship, but the chi-square will tell us whether there is a statistical relationship or it is just by chance that we are seeing this thing crudely. So let's see how do we perform the chi-square test. So basically you will have to state the null and alternative hypothesis. So in case of chi-square test, we have this common null and alternative hypothesis. So the null hypothesis will state that two variables are independent. So the chi-square test of independence. So basically what we assume or what is established is that the two variables are independent of each other. There is no relationship between smoking and alcohol consumption whatsoever in this relationship that we are saying crudely is just by chance, whereas alternative hypothesis will state that the two variables are dependent upon each other. Now we'll have to see if the null hypothesis gets rejected. That means that the two variables are dependent upon each other, which means that if a person smokes more, they'll end up consuming alcohol more, or vice versa. Okay, so or if the null hypothesis gets accepted, or we fail to reject the null hypothesis, the two variables are independent, which means that there is no relationship, no link between smoking status and alcohol consumption. So let's see. So how do we go about it? State the level of significance alpha, which will be given in the question. Alpha is equal to 5%. So basically we'll have to look in the question where we'll have the value of alpha. So over here they haven't given us the value of alpha, so but we have assumed that alpha is 5%, but normally in the questions they'll give us the value of alpha. So if we recall from the very first session of biostatistics, we remember that alpha is also called the level of significance, and it is also the probability of type 1 error happening. So basically this is how we calculate alpha. Plug in the values for each individual cell in the following formula and then add them all. So basically for each individual cell we'll have to calculate O minus E whole square divided by E. So what's O? O is observed frequency. E is expected frequency. The E over here in the denominator is the expected frequency. So for all of these individual cells, this one, 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 this one. So we'll have to calculate this thing for all of them individually. So this is the chi-square, sigma, which means sum of. O is the observed frequency, is the expected frequency. So here O is the expected frequency is given in the table. So where's the here O, that is the, so this should be observed frequency, it is given in the table, whereas expected frequency is given by the formula and is calculated individually for each cell in the table. So basically what we have to do, we have to actually see, so the frequency that is given over here is the observed frequency. So 1880, 2048, 194, all of them they were given in the question. So this value, this value, this value, this value, these are the observed frequencies. This one, this one. Okay, so we'll have to calculate the expected frequency using this formula for each of these cells individually. So how do we do that? When two variables are independent, the expected number of measurements, expected frequency falling in the cell I, J, cell of the ith row and jth column of the table is taken to be row I total into column I total divided by n, where n is the total sample size. Table 2 shows the notation for expected frequency for the okay, so what we have to do, we'll be calculating expected frequencies for each of them. So basically we are going to follow the same example. So these values, what they are the observed frequencies. So simply put, they are the observed frequencies. So what we have over here, we have the observed frequencies by simply looking in the table. But what we have to do, we have to calculate the expected frequency for each of these cells, so we can apply the formula for chi-square to each of the individual cells. So what we are going to do now, we are going to calculate expected frequencies. So how do we do that? So what we do now is we use this formula as discussed. So if we have to calculate the expected frequency for this particular column, how we'll do that? We'll multiply the row total into the column total divided by. So what's the row total for this this cell? This cell falls in this row, so the row total is 4198. We put it over here. Then we have the column total, so the column total for this cell is 67170. So we put it over here. We divide by the total sample size, and the total sample size is given over here. So we divide by the total sample size. We get the expected frequency, which is 2327.8, and we put it over here, 2327.8. Then likewise we go for the second cell, third cell, fourth, fifth, sixth, seventh, eighth. So just pick another cell at random just to see how we do that. So let's see over here. So this one expected frequency for this cell. So we multiply the row total, which is 47198, by the column total, which is 47478, 47198, and 4478, and we divide it by the total sample size, which is 11127, and this comes out to be 1689.4, which is written over here. So we do it for all the cells, except for the total cell. The cells which represent the totals, they are included. Except for that, we do it for this. So we already have these values which were given in the question. These are the observed frequencies. Observed, observed. And then we calculate what do we calculate? We calculate the expected frequencies. So this was the main formula: chi square is equal to observed frequency minus expected frequency whole square divided by expected frequency. So we already had let's see, we already have the observed frequencies from the question. We got our expected frequencies how? By using this formula and performing all these steps. And then what we did, and then we divide by the expected frequencies and we get chi square. So let's see, we filled out this table. We got all the observed frequencies and the expected frequency of observed, expected, for all of them. So we'll have to do it individually for all the cells. Now what? So if you recall, we had this symbol in chi-square test. So basically we'll have to add, we'll individually put these two and calculate chi-square for this cell, then we'll calculate chi-square for this cell, then we'll calculate chi-square for this cell, then 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 this cell. So in the end, once we calculate, so basically we'll be applying the same formula on each of the cells individually. So basically for the first cell, let's see, we have the observed frequency of 1880, so we put 1880 over here. Then we have the expected frequency for 2327, so we put 327 over here, and then we divide by 11,127, which is a total. So no, sorry, we don't divide by the total, we divide by the expected frequency, which is 2327. We divide it by the total once we are calculating expected frequencies. So how do we do that? Just let's see it again. Okay, so observed frequency and expected frequency, what we do, observed is 1880, we put in the value of 1880, then 2327, so we plug in the value of 2327, and then divided by the expected frequency, which is 2327.8. So here we have the chi-square for this cell alone. Then we calculate chi-square for this cell. How do we do that? We plug in the value of observed frequency, which is 2048. Then we plug in the value of expected frequency, which is 1689.4 whole square. Then we divide it by expected frequency, which is 1689.4. So we do it for all the cells, and then we add them all. So basically we'll calculate chi-square for this one, and then we'll add all of them. So 1, 2, 3, 4, 5, 6, 7, 8. So we'll get 8 individual values, and then we'll add all of them, and the result we'll get is the total chi-square value for this test. So now let's see how we'll proceed further. Okay, so here we have, so this value that we have calculated is the chi-square value, but it is specifically called the chi-square calculated. So this is the chi-square calculated value which we have calculated. Now we have another value which is called the chi-square tabulated, and there are a set of steps which we have to follow, and then we'll get to the value of chi-square tabulated. So basically we'll use the chi-square table to get this value. So calculated and tabulated. Then we'll compare both of them. and then we'll see whether we have to reject the null hypothesis or we fail to reject the null hypothesis. So how do we do that? If the value of chi-square calculated is greater than chi-square tabulated, it means that we are supposed to reject the null hypothesis. And what do we mean when we say the null hypothesis is rejected? Let's see what the null hypothesis originally was. So for all the chi-square tests, the null hypothesis, the two variables are independent. So if we end up rejecting the null hypothesis, which this means that the two variables are dependent. But if we fail to reject the null hypothesis, then the two variables are independent. So this is how we go about it. So how do we reject the null hypothesis, or when do we reject the null hypothesis? It is when the chi-square calculated is greater than chi-square tabulated. So let's see. How do we? So up to now we have the value of chi-square calculated. Let's see how do we calculate the value of chi-square tabulated. So chi-square tabulated is determined using level of significance alpha. Remember, we have already discussed what alpha is given in the question. It will be given in the question. Degrees of freedom TF, which is given by the formula for chi-square. Degrees of freedom is given by this formula, and then the value corresponding to both these values in chi-square table is the chi-tabulated. So basically we must know the level of significance, which in this case was 0.05. And degrees of freedom, how do we calculate it? We calculate it using the number of columns -1 into number of rows -1. So let's see how do we see. So we know the level of significance over here is 0.05. So we assumed it in the start of the of this example, but normally it will be given in the question. So now coming on to degrees of freedom, which is given by the formula. Degree of freedom is equal to, for chi-square specifically, degrees of freedom is given by this formula, column -1 into row -1. So let's see. So how many columns did we have? 1, 2, 3, 4. So number of columns is 4, and how many rows did we have? 1, 2. So let's see. Columns 4, rows 2. So 4 minus 1 into 2 minus 1, which means we have to multiply. Let's see. We have to multiply 4. Okay, so we have to multiply 4 minus 1, which is 4 are the number of columns, into, do not include the total column in this multiplication process, into 2 minus 1. Okay, so which means 3 into 1, which means 3. So degrees of freedom over here is 3, which we have shown over here. So this is it. What do we mean when we say okay, do not include the total column? We mean that we are not supposed to include this column in our total column. So 1, 2, 3, 4. If we include this one, this is the 5th column. We do not include it. So we just say 1, 2, 3, 4. So the number of columns is 4, not 5. So 4. And do not include a total row over here. So 1, 2, 3, no. 1, 2 only. 1, 2. The number of rows is 2. And then we subtract -1 from 4 and -1 from 2, and then we get 3. Okay, so how do we, so we have degrees of freedom, which is equal to 3. Then we have the level of significance, which is equal to 0.05. So let's see how we calculate the chi-square tabulated. So basically we'll have to use the chi-square table. What two values we'll have to look up in the chi-square table? Level of significance, which over here is 0.05, and degrees of freedom, which over here is 3. So let's see. Okay, so we'll go towards the chi-square table to calculate chi-square tabulated. Remember that we have already calculated the value of chi-square calculated. So let's see. So this is a chi-square table. We'll be provided with it during the exam. So we have degrees of freedom over here, and we have level of significance over here. So let's see. If we recall, we had, in this case, degrees of freedom was 3, and then we had 0.05 as the level of significance. So basically we'll see where both of them intersect. So let's see. This is how we calculate chi-square normally. So 0.05 has to intersect somewhere over here. Then 3 has to go over here. So basically it's like this. So 3, which means 7.81. So this is the point of intersection, 7.81. So this is the value of chi-square tabulated. So let's see, the value of chi-square tabulated comes out to be 7.81. So what now we have to do is, we have to compare both these values. Chi-square calculated is 338.7, and chi-square tabulated is 7.815. So chi-square calculated is 338.7, chi-square tabulated is 7.851. So chi-square tabulated is obviously lesser than chi-square calculated, or chi-square calculated is more than chi-square tabulated. And if this happens, what we are supposed to do, we shall reject the null hypothesis if chi-square calculated is greater, which obviously in this case it is greater. So what we do, since chi-square calculated is greater than 7.851, which is chi-square calculated, which is chi-square tabulated, we found this out from the table. So chi-square calculated is greater than chi-square tabulated, thus we reject the null hypothesis. At how much significance level? 5% significance level. This should be given in there in the question. So hence we conclude, so if we reject the null hypothesis, what did the null hypothesis state? Let's see. Null hypothesis stated the two variables are independent, but since now we have rejected the null hypothesis, this means that the two variables are dependent. So hence we conclude that there is an association between drinking and smoking among pregnant women, because the two variables are dependent. So in case they were independent, then there wasn't any association, but here in this case we have proved that there is an association. So that's it. I hope you did learn from this. This was helpful. So thank you very much.